Hello everyone, this video will talk about a question about osmotic pressure. In case quickly we can get to that point, and then this is something else, of course, relates to this question we need to calculate about. Okay, so let's see what that will be. Okay, so osmotic pressure, first thing first, we know in order to calculate that we need this equation, osmotic the pressure equals to I, Van House factor, multiply molarity, multiply R, multiplied by T, right? Okay, so the next equation itself, again, we understand that Van Hoff factor is related to the solute, right? And then what kind of electrolyte that will be. Okay, so now let's see this question. So what's our solute? It's sodium chloride. Okay, so then sodium chloride as our solute, what's its I value? Is a strong electrolyte. It's going to be completely dissociating into ions. So then from one ionic compound turn into two ions. So that's why the I value equals to 2. Okay, so then we can figure that out. Okay, so that's very good. Okay, so now the next information we need to know in order to figure out the osmotic pressure is that molarity. Okay, so we look at the question, we go, is the molarity given directly? Not really. We have a mass percent and we got density of the solution. That's pretty much information we can relate to calculating the molarity, right? Okay, so then you go, okay, hold on a second, that's something we need to figure out. Okay, and now let's keep on going and see what else we could easily figure out. Next will be the R value, which is the constant. Okay, so then the constant itself, we're going to use the R value as 0.08206. The reason for that, because the unit, right? So ATM times liter over mole times K, because again, we are calculating a pressure. The pressure in this equation, the units needs to be ATM, atmosphere, right? Okay. So that's that. And then the last term is temperature. The temperature, again, we also realize that unit needs to be K because we need to be able to cancel those units out. So then let's do a job. Since it's given as 37 degrees C, so we're going to convert it to Kelvin by plus 273.15. Okay, so then you can do that work. Okay, so then we can get our temperature. Okay, so then the temperature is, let's do a quick calculation. Okay. Okay, 310, 115. Okay, so that's for that. Okay, so then we got the temperature. Okay, and now we need to really just figure out what's this molarity, right? Okay, so then let's see how we can figure this term out, molarity. Okay, so molarity, as you just realized, when we have a mass percent, we have density. Now let's think about what's this about. Density is about the whole solution, right? Okay, and then we have a mass percent. Mass percent is 0.92% of your sodium chloride by mass in terms of the whole solution. Okay, so then you go, there's a relationship, but then you go, I still don't get it how I'm going to use this info. Then let's go for what does the molarity mean and how do we calculate that. Okay, so molarity should be moles of the solute, which is sodium chloride in our question, divided by liter of the solution. Okay, so the whole solution, which means, right, the solution is the solute plus the solvent. Okay, so then that's the situation. So then you go, okay, I have a volume of a whole solution, I have density of the whole solution. I think by, right, if I have a volume, I will be able to calculate the mass. Okay, so then here I go, here is the logic. Okay, so the logic will be assume, we're going to assume we have 1 liter of the solution. Then you go, why you're assuming a liter, not 10 liter or not just 0.1 liter? Why 1? Okay, the reason why 1, because look at this. Okay, look at the concept for molarity. The definition for molarity is moles of solute divided by liter, per liter concept. If we are already assuming, right? Okay, so this per liter, you can actually add a 1, right? Okay, so like this then. Okay, so if I put a 1 over here, you can also understand, right? I can calculate in 1 liter of solution how many moles of the solute I have, then that's my molarity, right? Okay, so then therefore I'm assuming I have 1 liter of solution. So then once we figure out in this 1 liter solution how many moles of solute we have the information for molarity, right? So that's why we assuming 1 liter. Okay, so once you assume you have 1 liter solution, that's the volume. We also have density. Now we're gonna do the calculation. 1 liter times 1 gram per ml. I'm gonna set up like this so we can see it, right? So we clearly can cancel out the units, but we need to do a conversion. So then that's gonna be 1,000 ml per liter. That cancels out. So in this 1 liter, what's the mass of the solution? Is 1,000 grams. This is the mass of the solution. Okay, so that's the mass of solution. Remember, we want to figure out the moles of the solute. Okay, so if we know mass of the solute, are we able to calculate moles? I believe so, right? So what's the mass of the solute by itself? Then very convenient, or oh, here the mass percent. That's gonna help us to figure this out, right? So the mass percent is 0.92%. So then the mass of the solute, or the mass of sodium chloride in this case, that should be, right, the mass of the whole solution is 1,000 grams, and then 0.92% of that, that's our solute, which is the sodium chloride. So then we do this calculation, that gets us to 9.2 grams of sodium chloride. Okay, so we got to this point, very easy to calculate, right? Or it's easy to handle, right? So 9.2 grams of sodium chloride, we need its molar mass. Okay, molar mass is 1 mole of sodium chloride is 58.44 grams. Cancel this out, we get moles, that's 0.157 moles of sodium chloride in 1 liter of solution. Okay, right? Again, that's what we assumed. Then that's what we got. Now look at that. Are we able to calculate molarity, right? Yes. Moles of the solute over liter of the solution. That's nice. Then we get our concentration, okay, in molarity. Okay, so now I got 0.157. Okay, so we got that. Van Hoff factor is 2. Molarity is 0.157, R is 0.08206, and the temperature that was 37 plus 273, right? Okay, so now you have all the values, plug it in, you'll be able to calculate the osmotic pressure, then the answer will turn out to be 8.0. Okay, so then that's how you can calculate this question again. Of course, once you plug all the values in, you should be able to cancel the units, right? See, that's Kelvin. You have molarity is mole, right? Mole per liter, that cancels out. That at the end you only get ATM, which is the unit we're looking for. Okay, so then this is how you do this question, and hopefully it's helpful.